Assalamu alaikum, dear students. I am Rashid Kiani, and today I am delivering my fourth lecture on the topic triangles, quadrilaterals, and polygons. This is chapter number 11, D1 Maths O levels, and in this lecture, we will discuss the quadrilaterals and types of quadrilaterals. The definition of quadrilateral is written in front of you. A quadrilateral is a closed plane figure having four sides, four vertices, and four internal angles. You can see the quadrilateral which is drawn in front of you. That this quadrilateral, this geometrical figure has four sides: AB, BC, CD, and AD. These are four sides of the quadrilateral, and the vertices are A, B, C, and D. These are four vertices. Obviously, it has four internal angles: angle at point A, at point B, at point C, and at point D. So this was the definition of quadrilaterals: any four-sided figure having four internal angle, four vertices, and its sides are the straight lines which are connected together from starting point to end point. Then the figure comes in front of you is called quadrilateral, and there are many types of quadrilaterals also. Let us discuss those types. So first type of quadrilateral is a rectangle. This is a rectangle which is in front of you. It has four sides: AB, BC, DC, and AD. In rectangle, the properties of rectangle, the first property is there are two pair of parallel lines. So AB will be parallel to DC and BC will be parallel to AD. These are four sides and opposite sides are parallel, and opposite sides are also equal in length. This is the second property, that opposite sides of a parallelogram are equal in length. You can see that BC is equals to AD and AB is equals to DC. So the opposite sides are equal in length. Third property is the all four angles are the right angles. In rectangle, all the four angles, four internal angles, angle at point A, B, C, and D are of 90 degrees. So all the four angles are of right angles. So, and the next and not the least, the two diagonals are equal in length. Diagonal bisect each other. Okay. So you can see in the diagram that AC and BC are the two diagonals of the rectangle, and they bisect each other. It means that the point where the diagonal intersect each other at point E is the midpoint of both these diagonals. That is, BE is equals to ED and AE will be equals to EC. The diagonals bisects each other, they intersect each other at the midpoint of each other. So these are two diagonals. So this was the first example of a quadrilateral, that is called rectangle. Okay, next type of quadrilateral is a square. You are very well aware of the square, the geometrical figure with four sides and whose all four sides are equal in length is called a square. So in the square, opposite sides are obviously parallel. AB is parallel to DC. It is shown by two arrowheads on AB and the line DC. That there are two arrowheads and both these lines are parallel to each other, and the line BC is parallel to AD and it is shown by one arrowhead on the line BC and AD. Both these lines are parallel to each other. Their diagonal intersect at an angle of 90 degrees. There are two diagonals AC and BC which intersects at an angle of 90 degrees. All four angles are right angles. All four internal angles of a square are right angles. The diagonal also intersects at an angle of 90 degree. So the point E is the midpoint of the diagonal. That is, the diagonal intersect at point E which bisects them. So this is the bisection point of bisection, that is the point E. and it means that BE is equals to ED and AE is equals to CD by length. So this was the scare having two pair of parallel lines. All four sides are the same length. All four angles are the right angles. The two diagonals are equal in length. Diagonal bisect each other at right angles. Okay, two diagonals are equal in length. That is, everything is explained over here. The diagonal bisect interior angles. So the next property is also mentioned that if C is the interior angle, then the diagonal AC bisects the angle at point C, as well as the diagonal AC bisects the angle at point A. The diagonal BD bisects the angle at point B and the at point D. So these diagonal bisects the internal angles of a square also. So these are the definition and properties of a square. The next type of the quadrilateral is a parallelogram. In parallelogram, opposite sides are equal in length. It means that AB is equals to DC and BC is equals to AD. These opposite sides are equal in length. The diagonal AC and the diagonal BD are there, which bisects each other. BE will be equals to ED and AE will be equals to EC. These are two diagonals, and you can see that the line AB is parallel to the line DC, which is shown by two arrowheads on the lines, and BC is parallel to AD and it is shown by one arrowhead on the line. This is the parallelogram. There are two pair of parallel sides. Opposite sides are equal in length. Okay, opposite angles are equals. That is, angle at point A is equals to angle at point C, and angle at point B is equals to angle at point D. The opposite angles are equal in length. Diagonal bisects each other, as I have explained. So this is a parallelogram, a type of quadrilateral. The next type of quadrilateral is a rhombus. In rhombus, all four sides are equal in length. It means that AB is equals to BC is equals to CD is equals to AD. All four sides are equal in length. Opposite sides are parallel. It means that AB is parallel to DC, which is shown by two arrowheads. BC is parallel to AD and it is shown by one arrowhead. The diagonals intersect at an angle of 90 degrees. AC is the diagonal and BD is also a diagonal. Both these diagonals intersect at an angle of 90 degrees. Let us discuss some other properties again. There are two pair of parallel lines I discussed earlier. All four sides are the same length, or four sides are equal in length. Opposite angles are equal. Obviously, as we have discussed in the type of parallelogram, rhombus, in rhombus also opposite angles are equal in length. That is, the angle at point A is equals to the angle at point C, and angle at point B is equals to angle at point D. Okay, the diagonal bisects each other at right angles. The point where the diagonal bisects each other makes an angle of 90 degrees. So the diagonal bisects each other at an angle of 90 degree. The diagonal bisects the interior angles. That is, it means that the diagonal AC bisects the angle at point C. The by bisection means to divide an angle in two equal parts. So the diagonal AC divides this angle at point C into two equal parts and at point A into two equal parts. At the same time, BD is the diagonal which bisects the angle at point D and at point B. So these are the few important properties of a rhombus. Now let us discuss the another type of quadrilateral, that is called trapezium. Trapezium only have one pair of parallel lines. That is, the line AB will be parallel to the line DC, but the line BC is not parallel to the line AD. It has only one pair of parallel lines. and the diagonal intersecting at point E, there is at least one pair of parallel lines. There is no such other properties of trapezium, but only the property of trapezium that it is different from other quadrilateral is that it has only one pair of parallel lines. In other quadrilaterals, there are two pairs of parallel lines, but in trapezium only there is only one pair of parallel lines. Okay, and the next type is the kite. Kite is also an example of quadrilateral. Here we have two pairs of equal lines. Two pairs of equal lines. That is, the line AD is equals to DC and the line BC is equals to the line AB. And it is shown by two cross lines over here on the line AB and the line BC. These are two lines which are equals to each other, and in the upside these are two lines AD and CD which are equal in length. Their diagonal, one is the greater diagonal and another one is the shorter one, that is the AC. Both diagonals intersect at point E at an angle of 90 degrees. So this is a kite. The opposite sides may be parallel. Opposite sides may be parallel. It means that AD can be parallel to the line BC and AB can be parallel to the line CD, but in not in general. In a particular case, the opposite lines can be parallel, but not always. So there are two pair of equal adjacent sides, as I have discussed. It has two pairs of equal sides. AD is equals to DC and AB is equals to BC. These are two pair of equal sides. Diagonal cut each other at an right angle. Obviously, diagonal intersecting each other at an angle of 90 degrees. That one diagonal bisects the interior angle. The one on only one diagonal, that is the diagonal BD, the greater diagonal, the larger diagonal, the diagonal greater in length bisects the interior angles, that is the angle D, and angle B is bisected by the diagonal BD, but AC is the diagonal which do not bisect the interior angle at point A and at point C. So these are the properties of a quadrilateral type kite. Uh, so these are very important types of quadrilaterals you must have to study, because we are in our next lecture we are going to solve exercise 11b, where the knowledge related to quadrilateral is very essential. So in my next lecture I will solve exercise 11b. I hope you understand this lecture today. If you have any question, feel free to ask me in the comment section, and do not forget to subscribe my channel. Till 11b exercise or till my next lecture, take care of yourself and thank you very much.